This is now the third part of our discussion for Module 1, which is all about measurement. And in this case, we will be talking about the different derived quantities. If you haven't seen the discussions that we had for the two previous topics, which are topic number 1, which is all about the presence of significant figures and scientific notation, and and topic number 2, which is all about conversion of units, please see, watch, and at the same time learn from those video presentations before you proceed with this part. For the derived quantities are simply defined as the combination of the fundamental quantities. Derived quantities include speed, acceleration, work, energy, force, and density. But in this module, we are just going to focus on two different types of derived quantities, and those are weight and at the same time density. When it comes to the pull of gravity here on Earth, the value it is actually equivalent to 9.8 meters per second squared. So this is now the value of the pull of gravity here on Earth. That is why on your previous discussions on your junior high school sciences, this is the value that we are using for us to get the value of weight. The gravitational pull that is present on different planets varies depending upon its size, the magnetic field, and the different factors that is present on those certain types of planets. But on Earth, always remember that the value for gravity is 9.8 meters per second squared. Now, if you're going to consider the concept of mass and weight, these two things are actually not the same. Your mass is not the same as your weight. Because whenever we are talking about mass, is now the number of molecules and substances in your body. Okay? So that is mass. While when it comes to weight, it is actually an example of a force. Weight is a type of force. Mass, it is a fundamental quantity, while weight is an example of a derived quantity. So when it comes to mass and weight, they are not synonymous terms, okay? Mass is also constant, while weight is always relative. How are we going to compute for the weight of an object or the weight of a person or a material? Now, the formula that we're actually going to use for us to get the weight, it is weight is equivalent to mass times pull of gravity. We're actually using also this particular symbols. W is equivalent to small letter m times g, or remove the multiplication sign, it is mg. Let's consider the weight of your teacher, Mr. Medina. Now, my mass as of September 2020, it is equivalent to 76.5 kilograms. Now, what is my weight here on Earth? Since the pull of gravity on Earth is equivalent to 9.8 meters per second squared, we can now actually get here my weight. W is equivalent to m times g. My mass is equivalent to 76.5 kilograms. Then we're going to multiply this with 9.8 meters per second squared. And now, my weight is equivalent to 749.7 kilograms times meter per second squared. Or, this value is also equivalent, or this unit, and this unit is also equivalent to newtons. So my weight is 749.7 newtons, or 749 kilograms times meter per second squared. So this is now my weight here on Earth. So that's actually how you're going to compute the weight of a material on Earth. Always remember to get its mass first, then and identify what is the pull of gravity that is present on that specific planet. Okay, there are actually some exercises that is present here. Why not try it out? Okay, because once again, practice makes permanent. Okay, so now let's proceed to the next part, which is now the presence of density. Now, whenever we are talking about the concept of density, density are also represented by the Greek letter rho, or just like a capital letter P, which is somewhat italicized. So this is our representation for density. Density, it is actually the word used to describe the comparison between an object's mass and its volume. When it comes to density, there are two things that we are going to consider here: the mass and the volume of a certain type of material. And the density will also give us the idea if that material will either float or sink, depending upon to what type of substance it will be incorporated with. What are the different things that you should remember when it comes to all of this? When it comes to the computation of density. So now, what are the different relationships of the different units that is actually present whenever we are talking about the concept of density? Now, if we're going to use the triangulation of formula, density, it is actually equivalent to mass over volume. So this is actually the triangulation of formula that we can actually establish or create. What if we are looking for density? Okay? If we're going to look for density, our formula it is mass over volume. Then, if we're going to look now for the volume, the formula that we are going to use it is mass over density. And lastly, if we want to know what is the mass of this material, we are going to multiply density with volume. So these are the different formulas that we can actually derive from this certain type of triangulation. Okay? So this is just a guide to every single one of you on how you're going to navigate answering different types of questions related to the concept of density. Let's consider one problem. Problem number 1. At this point, whenever we are going to answer different types of problems, I would like to suggest for every single one of you to use the Grasa method. The Grasa method stands for the following. G, it is for the given. Now, in this particular problem, a toy has a mass of 78 grams and a volume of 35 cubic centimeters. The given, the first one, the mass, it is equivalent to 78 grams. Then, for the volume, it is equivalent now to 35 cubic centimeter. Now, for letter R, it is now the required. For the required, what is being asked? For the required, we are looking for the density. So right here, density. Then, E, for the equation. And going back on the discussion earlier, our equation here is density is equivalent to mass over volume. So this is the formula that we are going to use. This, going back on our previous discussion earlier, this is the formula that we are going to utilize and which we are going to use for this particular problem. After the given required equation, let's now proceed with the solution. For the solution part, it is now known as the substitution of the different values that is present on the given. For the solution, write first what is being asked, which is the density. Then provide now the value of m, or the mass, which is 78 grams. Then now provide the value of the volume, which is 35 cubic centimeters. After writing down your solution and computing the last part of the Grasa, it is now the answer portion. And on the answer, you're just technically going to write what is your answer. And the answer for this problem, it is equivalent to 2.2 grams per cubic centimeter. Okay? And that is actually how you're going to solve problems following the Grasa method. Given, required equation, solution, then answer. Let's now consider here the concept of float or sink. Remember, if the density of the material is higher than the density of the solvent or of the liquid, the material will sink. But if the density of the material is lower than the density of the solvent or of the liquid, that material will float. Okay? So, it will float if the density of the material is lower than the density of the liquid, while the material will sink if the density of the material is higher than the density of the liquid. So this is just actually the relationship of the concept of floating and sinking when it comes to the concept of density. So basically, that is just how you're going to compute for the mass. That is just, okay. So this simply ends our discussion, and that is actually how you're just going to compute for the density and at the same time the weight of different objects. And if you have questions, please feel free to send those messages and utilize the time on our consultation for you to properly address those questions. Also, thank you very much, and I hope that you learned a lot in this video presentation. Thank you.